Alright, so this is going to go over the basic parts of algebra. I'm just going to cover the basic parts and that's it. I'm not going to go in depth. I'm not going to cover anything else, just the basic parts of algebra and equations, because that's what you need help with. So we're going to discuss that as we go. So first off, an equation is anything with an equal sign in it. So this is important. Before you've seen problems like this, and well, this is algebraic manipulation and simplifying. It is not solving. Solving happens when we have an equal sign. And the equal sign basically means that we have whatever is on this side equals whatever is on this side. So if we have 2 and we have an equal sign, it must always equal 2. Or if we have x, it must always equal x, or whatever x happens to be. But that's what an equal sign means. It means that left will always equal right. That's why we put them in equations, because we want to find something like this. We say x, so there's another thing right here. This is what we call a variable. So variables are kind of cool. They're variable, they change, depending on what we use them for. Every equation, x means something different. That's something to keep in mind. X may mean equal 3 in one equation, in one set of circumstances, but equal 4 in a completely other set of circumstances. So that's why x can equal multiple things. It just depends on what we're working with. The next thing to remember is x can be any letter as well. We can use A, we can use W, we can use Z, we can use a squiggle line. It doesn't have to necessarily be x. It's just anything that's standing in place of a number we don't know. So that's the key to variables. We don't know. And we need to solve to figure out what it is. So again, 2 things equations have for now. Equations will always have 1 equal sign, 2 a variable, and 3 filler. They'll have some other sort of numbers or something in the equation that will produce an x under a certain set of circumstances. It'll produce an answer under just that set of circumstances. So let's take an example here. If we have x minus 2 equals 4. So this is what we call an equation. This is an equation, because it meets all of our requisite parts. We have x, which is our variable, we have our equal sign, and then we have the filler, everything else. All the other numbers, all the other parentheses, everything besides the variable and equal sign are filler. They're only necessary to fill the equation to give us a set of circumstances. An equation just needs a variable and an equal sign. And then you can create an equation. But we have filler in this one to help us solve x under a certain set of circumstances. Now there's a couple of algebraic manipulations you can do across an equal sign. Because equal signs state that whatever you do to one side, you have to do the same to the other. And you can manipulate equations this way. So we, again, have gone over just the equal sign, that it's part of an equation, right? So equal signs are always going to be in an equation. That's the first thing that tells you we're dealing with an equation. And they'll always include words like in the instructions called solve, or find, or what does x equal. You'll see things like that in our before the equation. They'll tell us to either solve, find x, or what does x equal. This is important because it tells us that we're looking for something to fill in for x to make this statement true. When we use algebraic manipulation, we reverse the process to get the variable by itself equal to some sort of filler. And that filler ends up being our answer. Once the variable is by itself, we have an answer. Now, by itself means it has to be just x, or just y, or just z. It can't be negative x, or 2x, or x over 2, or x squared, or x to the negative 1, or 1 over x. It has to be this first one. You don't need to know what all these other things mean. But what we do need to know is these can't happen. We have to have x by itself for us to find an answer, and then equals. So that's what we're going to be solving for in this equation. We're going to be finding a number that makes this equation true. Makes the equal sign make sense. At this point, it doesn't. X minus 2 doesn't equal 4. Not necessarily, because we don't know what x is. We're looking for an answer that when we subtract 2, it will equal 4. Okay, so let's try it. Again, variable and a filler is what we're looking for. So we know that we have an equation, right? Because we have a variable and an equal sign. So now we can use the steps of algebraic manipulation. Let me go over some of these. So if we have a number subtracted by x, let's just do a variable. Okay. No, let's do a number. We add this number because x can't be attached to anything, right? And right now it's got a minus 2 attached, so we're going to add 2, and those will cancel out because we did the inverse process. We add 2 to 8, we get 10. X is 10. Now if we have x plus 2 equals 8, we're going to subtract 2, and then those cancel out because that's the inverse process, and we get x equals 6. Equations are all about using the inverse process to produce an answer. We're looking for something that equals x that can produce an equation. If you look back at these, if we take x, or 10, subtract 2 from it, we get 8. If you'll see that, if we take 10 and plug it in for x, this is true. We get 8 equals 8. That's what we want. If we get this, we take x, or 6, plus 2, we get 8 plus, or equals 8. So that's the premise. Now there's 2 other situations which we may see. So again, these are just plus and minuses. We have to do that first. So take care of your plus and minuses first. This is going to be your order for solving equations, okay? There's going to be an order here. One, we are going to add, well, first you're going to work outside parentheses. Two, we are going to, let me move this over. So we're going to work outside parentheses first. We're then going to work inside parentheses, or we're going to add and subtract. So once parentheses are removed, so let me put this. Let me say remove parentheses first. So we need to get the parentheses gone first. Okay. So whatever processes it takes to get those gone, do that. Then we add or subtract, combine terms, then multiply and divide. This is, if you'll notice, this is opposite from our order of operations, because our order of operations was used to build an equation like this. So we have to do the opposite in order to produce what we want. So if we have a 2x equals 8, and then x over 2 equals 8, well, now in this one we're multiplying by x, so we need to divide, right? So x equals, now that we're dividing, these cancel out because we did the inverse process. So the inverse process is the opposite process to what we're doing in the equation. Again, the inverse process is the opposite process to what we're doing in the equation. Now 8 divided by 2 equals 4. And you'll see if we plug it back in, 4 times 2 does indeed equal 8. Now we're going to solve for algebra using this method, x over 2. If we have x over 2, this case it's divided by 2, so we need to multiply because that's our inverse process. Again, multiplication is the inverse process, so we're going to multiply by whatever's on bottom, cancel it out, multiply it on this side. Because whatever you do to one side, you have to do to the other. That's the rule of equations. So now we're going to get x equals 16. And if you take 16 and divide it by 2, it will in fact equal x. So let's take an equation that's a little complicated. Using these steps, we're going to solve it. Okay, so the equation that I want to do is this one. We're going to take 2 times x minus 3 equals 4. All right, so this one seems really complicated when you first look at it. It doesn't have to be that bad. Just remember your rules. First, remove the parenthesis, right? Okay, we don't want that. So we're going to take this parenthesis. But what is this parenthesis multiplied by in order to remove it? Well, we need that 2 gone. So we're going to take and multiply by 2. Again, or divide by 2. This is the inverse process to the multiplication that the parenthesis is multiplied by. By doing the inverse process, we get just x minus 3. And then if you remember, whatever we do to one side, we have to do to the other. So we're going to divide this side by 2. So we get x minus 3 equals 2. Okay, now we're going to add 3 because it's the inverse process. Okay, we're going to add 3 because it's the inverse process, right? So these cancel out because that's the inverse process. And we get x, oops, that one doesn't cancel out. That one adds. We get x equals 5. And this should satisfy our rule that it's got to solve the equation. If we put 5 in here, 5 minus 3 is 2 times 2 on the outside right there, and that equals 4. So we get 4 equals 4. And indeed, our equation is true. So again, an equation has an equal sign, a variable, and filler. There's a couple of different basic operations we can do to change an equation and to make it look like what we want. To solve, if you will, for x. And so, real quick, running down those operations again, we have, you have your addition. So when something is subtracted from something else, we can add things across the equal sign, but whatever you do to one side, you have to do to the other side. We can subtract things across an equal sign, and we can multiply things across an equal sign, or divide things across an equal sign. And that's it for the video.